Alright, Unit 1, Lesson 4 ought to be fairly quick. There's not too much going on here, not too complex, and this assignment is only 8 problems long, so there's good news for you. We're going to factor a difference of squares, and we're also going to factor a sum or difference of cubes. The difference of squares is the one you're going to see a whole lot more, but nevertheless, we shall look at both. Let me just start by giving you the formula. Anytime you have a binomial that can be written in this form, a squared minus b squared, as in the numbers or terms in those positions can be, their square root can be taken. Well, then we can write this as a plus b times a minus b, and that is the really quick, snappy way to factor a difference of squares. Now, sometimes they're easy to recognize, sometimes they're more complex. For instance, one that might be really easy to recognize would be, let's say you're given x squared minus 25, and you're going to say right away, oh, well, yeah, we've got x squared. Okay, I can take the square root of that. It would be x. And I've got 25. Well, the square root of that is 5. That's not too bad. So if we're applying the formula, we're applying this formula over here to this problem, in this case we would say, well, a is equal to x and b is equal to 5. Because I could rewrite this problem as x squared minus 5 squared. Now, you don't have to. That's an unnecessary step. But as long as you recognize that 25 is 5 squared, you're going to be in good shape. So factoring this is a breeze. It's just x plus 5 times x minus 5. And you can check that for yourself to see that that is true. If you multiply that back out, what happens is you get this, the outer and the inner cancel each other out. When you multiply this 5 times this x, and then when you multiply this negative 5 times this x, those two terms wipe each other out, and you're left with just x squared minus 25, like we began with. So there it is. Real quick, real painless, right? Okay, well, they won't always look exactly like that. Let's say you have 16a squared minus 9k squared. We'll use a k just for fun, just to mix it up. All right, well, this is also a difference of squares, because what's the square root of each? Well, over here I could take the square root of that, and that would be 4a on the first term, and the square root of the second term would be 3k, right? Yep, so we'd have this squared and this squared, and there we have it, same thing. So what's the factored form? Well, it would be 4a plus 3k, my k will write, which apparently it won't, there we go, times 4a minus 3k. And it doesn't matter if you write the plus or the minus first. You could rearrange that and write 4a minus 3k, 4a plus 3k. That's not really a big deal. If you want to do that, that's fine. Let's see, can I come up with more of a challenge? Oh, sure, maybe, just a little bit. How about 4/9 minus y squared? But that's a fraction, and I hate fractions. That's all right. Put on your big girl pants or your big boy pants and deal with it. Yes, I know, that was very encouraging. You're welcome. That's what I'm here for, to uplift you and make you feel good about yourself. All right, 4/9. Well, I know it's a fraction, but if we treat the fraction as two separate pieces, you can see very clearly what the square root is. That is a perfect square, because the square root of 4 is 2, and the square root of 9 is 3. So if you took 2/3 and squared it, you would get 4/9. So then this factors to 2/3 plus y times 2/3 minus y. Alright, I'll do one more example of these, because this last kind is maybe the kind that could get you. Let's say you have p to the 10th minus p to the 6th. Maybe you don't recognize this immediately as a difference of two squares. But let's think about it. If you're comfortable with your rules for exponents, all right, exponential multiplication, then you would pick up on this. If we split p to the 10th into two parts, we could split it into p to the 5th times p to the 5th, right? Or p to the 5th squared. And the same with p to the 6th. It's p to the 3rd times p to the 3rd, or p to the 3rd squared. So it is, in fact, a difference of two squares. Whenever you're dealing with exponents, if it's an even number exponent like this is, right, p to the 10th, p to the 6th, p to the 22nd, p to the 38th, anytime you have an even exponent, it is going to have a square root. It is a perfect square because you can just take half of the exponent and square it. So this factors to p to the 5th plus p to the 3rd times p to the 5th minus p to the 3rd. And there it is. We've completed difference of squares. Alright, that's simple. Alright, good. I'm glad you feel that way. I've just decided that it's simple for you. If it's not simple for you, feel free to ask me for more assistance. Alright, now sum and difference of cubes. These formulas are really longer and more convoluted, and I'm not going to test you on this, so let me just tell you that ahead of time. Don't freak out about this. You'll have one homework question on each of these, and that's the last you'll see of it. I just need to introduce you to it. I'm not too concerned with you being able to do much of this. So if you can, just like we just had difference, I'll go ahead and do both of these at the same time. We'll do that. We'll do it that way. These two formulas. Now with squares, you can't factor the sum of two squares like you can the difference of two squares. And if you think about why that is, for instance, let's take that first example we had. We had x squared minus 25. Well, let's say I change that to plus 25. Think about why that doesn't work. Well, if you go, what are you going to put here? First of all, you've got a plus 25, so either they've got to both be plus signs or they've got to both be minus signs. And now if they're both going to be plus signs and you're going to put 5s here, well then you're going to have a third term. When you multiply that back out, that's going to equal, let me put a big thing here, this is not equal to this, because this is x squared plus 10x plus 25. Because these middle two terms are not going to cancel each other out now, because they have the same sign. Okay, so with squares, we could not factor the sum of two squares, but with cubes we can. And here come the formulas. You ready? All right, you're gonna love it. You're gonna love it. We've got a plus b times a squared minus ab plus b squared. Who doesn't love that formula? Everyone loves that formula. And the difference of two cubes is essentially the same thing. You've got a minus b times a squared plus ab plus b squared. So the only difference is that these two signs flip-flop in the sum or the difference formula. Let me get rid of all this stuff I just threw down here. Alright, so let's just look at one example of each, and that'll be sufficient. So let's say you have x cubed plus 27. Alright, what are we going to do with x cubed plus 27? Well, x cubed, obviously that's a cube, right? We can take the cube root of that and we would get x, because x times x times x is x cubed. But what about 27? Hopefully you recognize that 27 is 3 to the 3rd power. 3 times 3 times 3. So what I'm saying is we can rewrite this as x, let's think about this x in parentheses cubed, plus 3 cubed. So x would be our a for the formula, and 3 would be our b. So the formula is then a plus b, so that's x plus 3 times x squared minus ab. This middle term is a times b, which in this case is x times 3, or just 3x, plus b squared. 3 squared is 9. 3 times 3 is 9. And there it is. You have just factored the sum of two cubes. Done. Finito. And now let's do one that's a difference, just to mix it up. And here, I'll make it a little slightly more fun. Let's go 8y cubed minus 64. Now this one's got some funkadelic stuff to it. This you might not recognize right away because there's extra things going on. Well, you've got an 8 connected to a y cubed, but think about it, 8 is just 2 times 2 times 2. So this first term could be rewritten as 2y to the third power, because 2 cubed is 8 and y cubed is obviously y cubed. And then 64, maybe you don't know this one yet, but you will shortly. 64 is 4 to the third power, because 4 times 4 is 16. And anybody who's ever watched college basketball knows that 16 times 4 is 64, because forever that's how many teams got into the tournament, and there were 16 in each bracket, right? Of course, they've expanded it now, and there's more depending on the women or the men, but I think the women still have 64. But I digress. So now we can factor this, and our formula is right up there at the top of the screen still. So a minus b. Now keep in mind, a is this thing that's in parentheses here, and b is the thing in parentheses here. So a is 2y, b is 4. 2y minus 4 times a squared. Well, what is 2y squared? That would be 4y squared plus, what's a times b? 2y times 4 is 8y plus b squared, 4 squared is 16. And there you have the difference of two cubes factored. And like I said, I'm not going to do more on that because I just want you to have been introduced to it. You'll only have one of each kind of those to do on your homework, and then it will not be on your test. But the difference of two squares, you can count on seeing some more. Alright, like I said, short assignment, only 8 problems. Make it happen. Good luck.